This is exercise 3B, question 11. All right, we are given this shape with a set of coordinates and we are told to find certain things. We're also told that this shape is a rhombus, and that's really important because hopefully you know that means all the lengths are the same. So part A is asking us to find M, the midpoint of DB. Now, obviously that's pretty easy because we have these coordinates. So I'm just going to find the midpoint by saying we add the x's together and halve it. Then we add the y's together and halve it, and you can see that it is just 6, 6. So that's pretty easy. All right, let's look at B. Let's change colors. All right, part B asks us to find the value of C and B and A. So that is a little bit trickier. Now, the really important part of this is that we know that these lengths are all the same. So the distance between these is the same as this, same as this, same as this. So that's really helpful. The first thing I'm going to do is come up with, well, first of all, it's pretty easy to find C. So let's find C first. We know that the midpoint here is 6, 6, right? Which means is also the midpoint of these two, right? The midpoint is going to be 6, 6, and that is also these. So what I can say is that A plus B over 2 must equal 6, right? A plus B over 2 is 6, and 1 plus C over 2 is also 6, right? The y coordinates are also 6. This is immediately easy to solve. Right, 1 plus C is 12, so C is 11. So that bit's easy. This bit, not quite so much. So what we can say is that A plus B equals 12. And then I'm just going to leave this here because I'm going to use that in a minute. So first of all, let's just box that because that's the right answer there. But now I need to find both A and B. So what I'm going to do is I am going to use my information from the lengths, right? So I know that all the lengths are equal. So I might just pick another color so we're not getting confused. All right, so over here, I am going to, let's just box that over a bit. All right, I am going to say that AB, line AB, is equal to line AD. Okay, so AB is equal to AD. Now, the reason I'm using these two lines is because I only have one unknown, right? I know the coordinates of these two. I don't know A, so it's going to be easier. If I try and involve C, I know C, but I don't know B, so that's going to be too many unknowns. So, I mean, I could do it that way, but I'm going to do it this way. It doesn't really matter. All right, so the length of AB. So again, we're using the distance formula. So 2 minus 1 squared plus 8 minus A squared, square root of all of that. So that's AB, right? We've got 2 and 1 and 8 and A, and that is going to equal AD. So I've got 10 minus 1 squared plus 4 minus A all squared. Again, all of that is square rooted. All right, let's start doing something to this. So this is just 1, 2 minus 1 squared is 1. But then this is a FOIL situation, right? We've got two brackets, so we need to expand that. So then we have 16 minus, sorry, not 16, 64. 64 minus 16a plus a squared. And then this becomes 10 minus 1, 9 squared is 81. And then again, this is a FOIL situation. So I get 16 minus 8a plus a squared. All right, let's just move up a bit. All right, let's try and put some stuff together. So I end up with a squared minus 16a plus 65. And then that equals a squared minus 8a plus 97. All right, let's start putting some stuff together. I am going to bring this across here and this across here. So then I have 65 minus 97 equals negative 8a plus 16a. You'll notice my a squares have disappeared because if I bring either one to the other side, they cancel each other out. So then I have negative 32 equals 8a. So then a is negative 4. All right, let's put a box around that. Now, what I'm going to do is I am going to go back. So if a is negative 4, I'm going to come back to this, right? So negative 4 plus b is 12, which means b is 16. All right, so now I have A, B, and C. Oh, can't really see it down there, can we? A, B, and C. So we've done part B. Part C, Let's find another color. All right, part C, let's just box all that around, asks us to find the perimeter of this shape. Now, as you know, it's a rhombus, so all four of them are the same. So all I have to do is find one length, and because I know A, B, and C, it doesn't matter which side I find, they're all the same. If I just find one of them, then I can just times it by 4. What I might do is put this up here so I can use this for later. So then the side of AB, so let's find AB. Why not? It really doesn't matter. So AB, the length of AB is 2 minus 1. Oh, that does not say minus. 2 minus 1 squared plus, so we've got 2 minus 1 squared, and then 8 minus A, and we know that that is -4. So it's 8 plus 4 squared. So, and all of that is square rooted. So that is the square root of 1 plus 144, so it's 145. So it's root 145, and we need 4 of these, so the perimeter is 4 times root 145, right? You can't simplify this third, so that is the perimeter. All right, now we need to do part D. Part D is asking us for the area of the rhombus. Now, you may or may not remember the area formula of a rhombus. I'm going to move us over a little bit and down so we can see. I do not have a lot of room. You know what? I am going to erase that and put it up next to it. So we have 4 root 145. I'm just going to leave that up there so I can use this bit. All right, let's change colors again. All right, so part D asks us to find the area. Hopefully you remember that the area of a rhombus is half times both the diagonals. So diagonal 1 times diagonal 2. So what we need to do is find the lengths of these diagonals and just multiply them by each other and by half. So it's going to be half times, what have we got? Let's move it across so we can see it. All right, we have C is 11, so let's do this one first. So we've got 11 minus 1 squared plus 16 plus 4 squared. Again, all of that is square rooted. And the other diagonal is going to be these two here. So we've got 10 minus 2 squared plus 4 minus 8 squared. And again, all of that is square rooted. All right, so let's do that. So it's half times, here we have 100, that's 10 squared. And then this is 20 squared, so 400 times the square root of 10 minus 2 is 8 squared is 64. 4 minus 8 is -4 squared is 16. So then we have half times root 500 times root 80. And if you magically work out what that is, it's 100 exactly. Isn't that so nice? All right, so that is it. That's kind of all you got to do. So this is the area, 100 units squared, I guess, if you want to say. We're not given what the units are, but it is 100 units squared is the area of that rhombus. All right, and that is question 11.